Alright, so in this lesson we're going to use HSMWorks to go over having various tools be used so that you'll do first center drills, then you're going to grab a number 11 drill just the top part of the metal, and then you're going to do this bearing hole with a 1/2 inch end mill, and then it's going to go down quickly to the bottom side, do the text. And then that's it for this this one job setup. All right.
Okay, so now I want to talk about what files you need to get. So in Google Classroom, there should be an assignment under classwork with the words Tormach in it. It's Tormach Mill project. And basically, I'm going to open this up. And you'll see there's different files here, and some of them are videos, and some are libraries, some are post-processors. So we're going to basically be getting these. Okay, so first things first. With the SolidWorks file for the mill project, it's this file here. So this file, you're going to download. I'm going to hit download, and I'm going to put it into my H drive. The H drive you have, and I can make myself a new folder if you would like, and you'll have this for all 4 years if you're SDA all 4 years. So I'll call it Metals Class. So I'm going to open that up. And then I'm going to save it there. So this is my SolidWorks file. If you are doing the mill project, you're going to need the library. And so this file right here, Tormach CNC Mill Aluminum, this file is a library file. What you have to do right now is click the 3 vertical dots, hit open in a new window, and then you're going to download it. Again, not the downloads, but you're going to go into your H drive and save it. Okay, next up, if you are doing the CNC lathe, or in the future, while you're at it, grab this library as well. So this is the lathe library. Open in a new window and download it. Then the last thing you really need to get is the post processors. So if I click this, notice it's a .zip, it's a zipped file. And so I'm going to hit the 3 dots here, hit open in a new window, and I'm going to go ahead and download it.
I'll see you.
Now with this file here, notice that it says .zip. So I'm going to hit this up arrow key, hit show in folder, and you can see here how the folder has this zipper on it. This means it's compressed and not really usable. So I'm going to right click it, hit extract all. Where do you want to extract it? Right here is good. Okay, so now this file, we don't really need this zipped one, but if you want to know if you did everything correct, in the post processors folder, in here we have post processors for all of our machine. I know you might not know what that means yet, but you will soon. We have our SolidWorks file to open up, and we have our 2 library files. So that's a summary of the stuff you need to get started. Next up is the tool library. So in tool library, when I click this button here, what we want to have happen is we want to get the library for our machine in our shop. all this other sample stuff is not what we have in our machine. So what I'm going to do is in the white area here, I'm going to right click, hit add library folder. The computer says, hey, where's your library folder at? Well, it's in my drive H, and it's in a folder called metals class. That's what I called it for mine. Okay, and then I have to tell it where it's at, and basically it's just in this folder, in the root of it, we'd say. So I hit OK, and now it's prompting me to basically give a name. At least it was, and I could type in there SDA or metals class. And so now let me go ahead and minimize this other stuff here. So now it found two libraries here. This one is for my lathe. We have 8 tools. And then this one's for our mill. We have up to 15. And so this library represents what's in our machine. And we've taken the time to, put the right offsets and measurements and stuff. So that's how you do it. That's how you get our library in here. Again, I press Tool Library. I right-clicked anywhere in the white area and hit Add Library Folder and told it where I downloaded that from.
I'm going to go ahead and delete everything here. And we're going to go through it. So first we're going to do a new job. And we're going to be using this coordinate system right here. So make sure for coordinate system that you click this one right here and make sure that the X is going positive to the right, the Y is going this direction, and Z is like that. So make sure we're using the upper left corner as a coordinate system and it's the top of the part. And of course we have milling checked here. So that's it for the job. And first thing we're going to do is we're going to do a center drill. So I pick a drill, and as far as the library goes, you're going to have downloaded the library already from Google Classroom, and we're going to be using the Tormach CNC Mill aluminum. And the center drill is, find it here, right here, tool number 7. So tool number 7 is a center drill. And on the next tab over, we're just going to pick the top edge of each of these guys. And right here, we're going to go from the bottom, we're going to go negative 0.06. So that's the one thing you have to know. Just from this top edge, we're going to go 0.06 below that. And let's just see how that turned out. So if I simulate it, go a little faster. And it looks like I forgot one thing here. The nice thing is that you can always go back in here and you can edit these. So I could edit this, go back and make changes. For example, if you forgot, if I forgot to grab this one, I could do that, and maybe I had a mistake there. So you can always go in and make changes really easily. All right, so that's done. After that, we're going to go ahead and drill it. And as far as the library goes, it's going to be the number 9 tool. So our number 9 is in fact a size 11 drill. So make sure you get number 9. And for this one, just this time we're going to click the bottom edge of the circle right there. The bottom edge of that circle. you get a mistake, just hit delete here, and you could redo it. Then what you want to do now is we're going to check this box. You should write this down. We're going to drill tip through the bottom, and then this is going to be a positive number, 0.05. I know you might think it's negative, but 0.05. So we're going to go past the bottom edge by just a little bit. Make sure we drill the hole. And then that should be it for that. And I'm also going to kind of name these as I go. So this is going to be number 11, drill. This one's going to be center drill. Okay, so now we're going to do something different than drilling. We're going to do 2D milling, and we're going to do a pocket. The bearing hole right here is going to be a pocket. And we're going to use the largest end mill that we can. In our case, tool number 1 is a 1/2 inch end mill. It's a 1/2 inch flat mill. So make sure you write that down that we're going to do that. So that's what we're going to use. As far as the feed rates go, that's a different lecture, but we're going to trust that what's in here is good. The main thing is that about 17 inches a minute. We'll talk about that a different time. Okay, next tab, we're going to hit the bottom of this. I know that you could do the bottom of this right here, but it would take a lot of time, and I'll try and explain it. But so we do that, and right here, everything is good. Everything's fine here. So really, that's it. And what's going to happen here? Now, if it has an error here and it says it'll say none there, I've had this happen to where on this tab right here. Right here. This is ramping is how the cutting tool enters the hole. And some of these will make it not work. So basically a side note is that I'm using the Helix one, and that one works well, but sometimes that can cause an issue. So if I simulate this guy, comes down, and that's it. So that works good. All right, so that's done. Now we're going to do, instead of having to go really, really slow down here and taking many minutes, we're just going to do the same operation again, the same thing, but by doing this, it'll rapid down to the second one and be very, very quick. So that's the reasoning behind doing that. Okay, so we got that done. Call this top bearing hole. Bottom bearing hole. Now we're going to do something different, which is called a chamfer. And a chamfer basically takes a sharp edge and turns it into a non-sharp edge. That's one purpose of a chamfer. It might also help to slide the bearing in a little bit easier. But basically, for our chamfer, it is going to be, all right, so in our library, you should write down that our chamfer mill looks like this, and it's just going to take that sharp edge off. It's tool number 5. And I'm just going to click on the top edge of this bearing hole, like that. And then over here, on this 4th tab, it says 2D chamfer. For this first chamfer width, I'm going to put 0. And the only thing to write down really here is that this box here, as far as I know, is the main one that controls like how much you want to chamfer. So 0.02 is the number to write down there. So for chamfering, we're in this tab called passes. The second blank says 0.02, and we're using tool number 5. And if we did it right, it should do it. Just goes around there, takes off the sharp edge. Okay, then the last thing is doing our engrave. And so for engrave, we've done this before by pick engrave. And the library tool we're going to use is number 10. And I will say that I think in the library right now it's at 40 inches per minute. It's too fast. So I'd write yourself a note that we're going to change this permanently, but I think 15 is going to be better. So it's going to have it cut slower. So that's at 15. And this is the main number to pay attention to, right? Cutting feed rate. That's how fast the tool moves. All right, so then I have to get that picked. So I got the top edge of that. And how deep do you want to go? Just like 10 thousandths. So 0.01. It's going to come down and do that. Ideally, we'd have a stick font as opposed to having it do both edges, but we're working on that. So then what you want to do after this is do a stock simulation. It's similar to simulate, but I click this, and you can go up here to stock simulation. And slow it down. Make sure, imagine your vise here. Is your vise going to get hit by anything? And really try and inspect everything before you post-process it. So make sure you do that, and you'll see with the bearing hole, it does just the top quickly. Then it's going to wrap it down fast and do the bottom. There's the chamfer. So it looks good, and then now you want to post-process it. So make sure that this ... is pointing to your folder, which hopefully...
At this point, basically, I have different machines. So if we're using the mill, we're going to use the Tormach 1100 CNC Mill. I'm going to double-click this thing and then hit Open. And notice that down here, it now has an entry for Tormach. So I've done that correctly. And then you can post-process your file. If you're doing the lathe, ... I would say, hey, I'm going to be using the slant lathe. Double-click it. And then tell it to open it up. And then now it's got it right there. So if you see it in here, you're golden. And then when I hit post-process, generally I would put it to my H drive, even though you need it on a USB drive. I'd put it on my H drive, and I would generally start with a V for version. So version like version 1, and I would call it, practice part. You could put your last name if you want, or something like that. But definitely version 1's important. And then you'll save it, but it does have to be on a USB drive.
Here's my G code. Again, it's nice having these labels, center drill, number 11 drill, because as the code's going, you actually, instead of having it say something random, these labels help you to know, because sometimes you want to start midway. Like the bell rings, you got the center drill, tomorrow you want to start with this, line 29, you could do that. Okay, so that's the exercise, and then you'll make this on the mill and get points for this and kind of be certified on that machine. There'll be another video showing you how to use the machine with this part.